we try to find out the Laplace transform of a fifth elementary function. That elementary function is a ft equal what? Ft equals sine 80. Sine 80. So, we may find this one linear transformation of sine 80 using the definition of directly using the definition of Laplace transform and find the value of integral e to power minus st sine 80. Another way is because we know that the Laplace transform of e to power 80 is a 1 upon s minus a. So, if we write a sine 80 in term of a what? In exponential term. So, what is the value of a sine 80? Sine 80 can be written as e to power I 80 minus e to power minus I 80 upon what? 2i. Because we know that what is the sin x? Sin x equal what? Sin x equal e to power ix minus e to power minus ix upon what? Upon 2i. So, here in place of x, what is the, here in place of x we write a 80. So, e to power I 80 minus e to power minus I 80 upon 2i. So, rather than to find out a Laplace transform of a sin 80, we find a Laplace transform of a e to power I 80 minus e to power minus I 80 upon 2i. We may also find directly by the definition of a Laplace transform. But here we are going to find out Laplace transform after writing the sin 80 equal to e to power I 80 minus e to power minus I 80 upon 2i. So, now by definition of a Laplace transform, L of sin 80 equal Laplace transform of what? E to power I 80 minus e to power minus I 80 upon 2i. 2i with a constant, so we may take it outside from the braces. So, 1 upon 2i and here Laplace transform of a what? Laplace transform of a e to power I 80. Basically, here I am using the linear property. Later on we discuss about linear property. E to power I 80 minus Laplace transform of e to power minus I 80. So, as we know that what is the Laplace transform of a e to power 80? 1 upon s minus a. So, here what is the a? In place of a here what? I a. Here what? Here minus I a. So, this become 1 upon 2i inside the braces what? Laplace transform of e to power I 80. Laplace transform of e to power 80 is a 1 upon s minus a. So, Laplace transform of e to power I 80 become what? 1 upon s minus I a minus 1 upon Laplace transform of e to power minus I 80 become s plus I a. So, if we simplify this result, this become 1 upon 2i and denominator become what? S minus I a, s plus I a. So, we using the a square minus b square equal a plus b and a minus b. So, this become s square minus I square a square and in a numerator this become s plus I a minus s plus I a. So, if we simplify, s and s cancel out and this become 1 upon 2i, in a numerator this become 2ia and in a denominator I square become minus 1. So, this become s square plus a square. I cancel out, 2 and 2 cancel out. So what is the value? Value become a upon s square plus a square. This one is the what? This one is a Laplace transform of a sin 80. This is the Laplace transform of a sin 80. Laplace transform of sin 80. Sin 80. So Laplace transform of a sin 80 is a upon s square plus a square. In a similar manner, be also able to find out a Laplace transform of a what? Laplace transform. Next elementary function is a what? Fifth elementary function. This one is a fifth or fourth? This one is a fifth one. So sixth elementary function is a what? Sixth elementary function is a ft equal cos 80. Cos 80. Now how we find the Laplace transform of this one? Again, we may able to write this one as a e to power I 80 plus e to power minus I 80 upon what? Upon 2. As we find the Laplace transform of a sin 80, again we find the Laplace transform of a cos 80 using the Laplace transform of a e to power 80. So now Laplace transform of a cos 80 equal Laplace transform of a e to power I 80 plus e to power minus I 80 upon 2. So this may be written as 1 upon 2 outside using the linearity property. Laplace transform of a e to power I 80 plus Laplace transform of a e to power minus I 80. So as we know that this become 1 upon 2 Laplace transform of a e to power I 80. Laplace transform of a e to power I 80 become what? 1 upon s minus I a. Because e to power 80, Laplace transform of e to power 80 is a 1 upon s minus a. So e to power I 80 become 1 upon s minus a plus 1 upon s plus I a in a similar manner, and this become 1 upon 2, and if we simplify in a denominator, this become s square plus a square, because I square become minus 1. So this become s square minus I square a square. I square become minus 1. So this become s square plus a square, and in numerator this become s plus I a plus s minus I a. So this one cancel out. After simplification, what is the Laplace transform? This become 2s, 2 and 2 cancel out. This become s upon s square plus a square. This is the Laplace transform of a cos 80. Cos 80. This is the Laplace transform of a cos 80. So now next elementary function is a, in a similar manner be able to find out a Laplace transform of a what? Laplace transform of a sine hyperbolic 80. Laplace transform of a sine hyperbolic 80. ft equal this one. Ft equals sine hyperbolic 80. Now by definition of a, again if we write before using the definition of a Laplace transform, so if we write more clearly here, ft equal what? Seventh elementary function is a ft equals sine hyperbolic 80, and in sine hyperbolic 80 can be written as in term of exponential form e to power 80 minus e to power minus 80 upon 2. E to power 80 minus e to power, once we verify. Okay. So e to power 80 minus e to power minus 80 upon 2. So now Laplace transform of sine hyperbolic 80 equal Laplace transform of e to power 80 minus e to power minus 80 upon 2. So 1 upon 2 we come outside. So, we may write 1 upon 2 we come outside. Inside Laplace transform of e to power at minus Laplace transform of e to power minus at, and after simplification this become 1 upon 2, and we know that Laplace transform of e to power at is a what? 1 upon s minus a minus Laplace transform of e to power minus at, 1 upon s plus a, 1 upon s plus a. So, this become what? 1 upon 2, this become s square minus a square, and s plus a minus s plus a. So, minus minus cancel out. After simplification this become a upon s square minus a square. And last elementary function is a what? Eighth elementary function is a ft equal cos hyperbolic at. We may write the cos hyperbolic at in exponential form, and exponential form of a cos hyperbolic at is a e to power at plus e to power minus at upon 2. So, now Laplace transform of a cos hyperbolic at equal Laplace transform of a e to power at plus e to power minus at upon 2. So, we may use the definition of a Laplace transform, or we may use the Laplace transform of a e to power at and using the linearity property. So, this become what? 1 upon 2 inside Laplace transform of a e to power at plus Laplace transform of a e to power minus at. So, as we know that 1 upon 2 Laplace transform of e to power at is a 1 upon s minus a plus 1 upon s plus a. So, after simplification this become 1 upon 2, in a denominator this become s square minus a square, s square minus a square, because s minus a into s plus a means using the formula a square minus b square equal a plus b into a minus b, this become s square minus a square, and in a numerator this become s plus a plus s minus a plus a cancel out. So, this become what? This become, after simplification this become s upon s square minus a square. This one is a what? Laplace transform of a cos hyperbolic at. So, these are the some Laplace transform of a elementary function. So, if we summarize the here Laplace transform for elementary function, which is treated as a formula, means in order to solve the numerical problem we must remember the Laplace transform of a elementary function, then be able to solve numerical example using some more property of a Laplace transform. So, once we write a what? Laplace transform of a all elementary function. First function is a what? Laplace transform of a 1 is a what? 1 upon s. 1 upon s. Second is a Laplace transform of a t is a 1 upon s square. 1 upon s square. Third one, Laplace transform of a t to power n equal gamma n plus 1 upon s to power n plus 1 or factorial n upon s to power n plus 1, because gamma n plus 1 equal factorial n. Factorial n. So, this one is a Laplace transform of a t to power n. Fourth, Laplace transform of a e to power at. E to power at is a what? E to power at is a 1 upon s minus a. Fifth one, Laplace transform of a sin 80 equal a upon s square plus a square, and 6-1 is a what? 6-1 is a Laplace transform of a cos 80 equal s upon s square plus a square. 7th one, Laplace transform of a sine hyperbolic 80 equal a upon s square minus a square, and 8th elementary Laplace transform of a 8th elementary function is a what? Cos hyperbolic 80 equal s upon s square minus a square. So, this one is a what? These are the Laplace transform of an elementary function. Laplace transform of elementary function elementary function. So, Laplace transform of elementary function. Laplace transform of a elementary function. So, in order to solve any numerical problem, we must know the Laplace transform of these elementary function, and here also we write Laplace transform of means a general any function. Laplace transform of ft equal what? 0 to infinite e to power minus st ft dt, and this one equal fs. So if we talk about so here we discuss about a Laplace transform of an elementary function. So here one thing is missing here. If we closely observe, this must be s here, s greater than 0, and here also s greater than 0, and here in case of a Laplace transform of a e to power at, it must be necessary s greater than e. In case of a Laplace transform of a sin 80, s must be greater than 0. Similarly, Laplace transform of a cos 80, here also s must be greater than 0. In case of a Laplace transform of a sine hyperbolic 80, it must be what? Here we write Laplace transform of a sine hyperbolic 80. So, this one is a s minus a and s plus a. So, s must be greater than plus a. So, here we write here s is greater than plus a and s is greater than minus a. So, here we may write s must be greater than mod of a s must be greater than mod of a in case of a sine hyperbolic 80. And similarly, for cos hyperbolic 80 also there is a s minus a and s plus a. So, this one also here s must be greater than mod of a mod of a. So, here we have missed out this one. So, sin 80, in case of a sin 80, s is a greater than 0. Also in case of a s minus a, s is a what? S is a greater than a. And here s must be greater than 0. S must be greater than 0. Also here we write s must be greater than 0. S must be greater than 0. So, in table, if also we mention here s must be what? Here if we write with a different color, s must be greater than mod of a. Here s must be greater than mod of a. S must be greater than mod of a. So, these are the Laplace transform of some elementary function. We may treat these Laplace transform of these elementary function as a formula. So, it must be necessary we remember these formulae in order to solve a numerical problem.